Hello, namaste. It's me. It's me, Rohan Byanjankar, and in this video, I will simply demonstrating an Excel program that runs a program written in EViews and finally displays EViews output. You just need to simply click on the buttons on Excel, and this program is especially designed to assist students carrying out thesis and researchers to perform time series analysis. So now let's highlight on some features or what the program performs. First it performs log transformation of variables. Second, estimates the growth rate of variables. Third, performs unit root test, that is ADF and Phillips-Perron test. Performs OLS estimation. Fifth is performs Engle Granger two-step procedure for cointegration. Sixth is perform ARDL cointegration. Seventh is report result of all the model with their appropriate diagnostic test. Features of this program are: you can add up to 15 independent variables, you can change the variables and data associated with it and run your own model, and and I have written this program, and you can contact me at rohanbjkr@gmail.com. So now let's highlight the data part. This is the yearly model. This is the yearly model, and you can choose any of the macro variable, or you can modify this data according to your country data. And let's have a look over the model part. And the model part, you can choose the dependent variable and a list of independent variables. For this I have taken the CPI as dependent variable and import NGDP, exchange rate, and aid as the independent variable. Prior to this, I want to go to the description part. If you want the description of the data and the sources, then you can find it here, and you can also find the values, such as the revenue is in value of million, and the CPI is as the index of 2010, and so on. So now let's return to the model part. And now you model in EViews, and you can ignore the constant part because it's added automatically. And the model is CPI is the function of import NGDP PC exchange rate and aid. This is a simple demo video, so I haven't added all the variables that affect CPI. And let's add M2. I think we can add M2 also, but for this is a simple demo video, so these variables may or may not be relevant. And if I add M2 here, then in the EViews model, the M2 will be added automatically. So now the next step is EViews exe file. We must choose the file path of EViews exe. So now let's perform it. EViews 9, and this is the exe file of EViews. Let's click on OK. Similarly, EViews program folder, we must choose the EViews program folder as EViews program folder. Click on it, and let's choose it. It's, I think, state analysis and EViews program folder. OK. And we will choose the EViews work file or the EViews output folder. OK. So now we are ready to run the model now. So now let's click on run model. So now model will run automatically, and it will close as it finishes its operation. And now let's click on view output. If you click view output, then automatically the EViews work file will open. And now As mentioned earlier, it's perform ARDL model, it will perform the simple OLS, and it will perform the Engle Granger two-step procedure, that is ECM short run and the OLS long run. And these are the diagnostic tests. First of all, let's check the ARDL auto. It means that the test of autocorrelation. If I click on it, then the Bruce Godfrey serial correlation LM test. It's a test for the autocorrelation, and we will only see the figure of OBS R square 5.52, and it's greater than 0.05. So we can claim that the model is free from autocorrelation. And the bound test, let's see bound test. We will see the F statistics, and it's 18.16. It means that and we will see the critical bound value. The critical bound value must be greater than the critical values mentioned in this part. And the critical value and the F test is F statistic is 1.16. It's greater than 4.15. So at 1% we can say that the null hypothesis is not accepted or it's rejected. It means that long run relationship exists. So now for the test of it's the main model, it's the cointegration relationship. It's the main model, and we will see this result. This part is the short run part, and this is the ECM term. It means that it's the error correction term, and it must be negative and significant at 1% or 5%. 5%, and the negative coefficient says that the long run relationship exists. And this is the long run coefficient as mentioned here. These are the long run coefficients, and we only see the value of probability. It's less than 0.05, then we will interpret it. It's not less than 0.05, then we will simply ignore it. So it's the test of the corollagram. It's the test actually of the residuals, and it must lie between this band, this dot line. It must lie between these bands, and it's the square of the corollagram. And the same rule, it must lie between this band, and it must be sometimes negative, sometimes positive as earlier. Means that this is also same, it's positive, it's negative, positive, negative, and so on. It's the Kusum test. It's the test of the stability of the model, and it must lie between these red lines or these bands. Similarly, it's the square of Kusum test, and the rule is same. It must lie between these band for the stability. Since at this part it's outside the band, so the model may not be stable. The model may not be good enough. We must revise our variables or model. And its ARDL hist means the histogram, and we will only see the Zargabera and the associated probability. The probability must be greater than 0.05. P-value must be greater than 0.5 to ensure that our model the error terms are normal distributed or normality principle. And the reset test is the Ramsey reset functional distribution test, and its null is that there is no omitted variables, and its alternative is that there is omitted variables. And the F statistic says that it's 0.000, means that functional misexpression exists. So we must be careful in it. Then we must also add the square terms of some of the independent variables, and it's the residual figure. It is the graph of the residuals. It seems that the residuals are normally distributed, and its appropriate white noise also. The ARDL white means the heteroscedastic test or White's test, and we will see the observation OBS R square. It's the chi-square it gives the chi-square value is 11.59, and the probability must be greater than 0.05 to ensure that the model is free from heteroscedasticity. So now all these results, all these diagnostic tests are related to the ARDL, and similarly these diagnostic tests are real to the OLS ECM, that is electrocorrelation term. Similarly, this must be negative as seen in the ARDL. And here we can also see the DW Watson statistics. It's the statistics for the autocorrelation, and this statistic must be near to 2. This seems that the model suffers from autocorrelation, so we must estimate HAC standard errors, that means heteroscedasticity and autocorrelation corrected standard errors. I think the model will run it, or we can run it by estimating and options and uh, covariance method HAC and OK. Then these standard errors are robust or are immune to the autocorrelation and its heteroscedasticity problem. I think we shall collect, or I must correct this part in the model or in the program, and the similar is for the all, and the uroot or the uroot tables are the test tables for the unit root, and and you can clearly distinguish that D means difference, ADF means ADF test for aid, difference ADF test for CPI, and similarly unit test DD. PP means Philippine for aid. Similarly, the L means its labels, and the labels ADF test 8, labels ADF test CPI, and so on. And if you have any queries, then you can email me to rohanbjkr. You can simply email me to rohanbjkr@gmail.com. Thank you.